Hello, my name is Scott Mesjian, and today I'll be doing discussion section 8, problem 1 for uh, week 2's explainer video. This problem is quite long, but basically what you need to know is that we're going to be finding the largest mass of a rock that we can put in a hemispherically shaped boat of mass 21 grams and of diameter 8 centimeters. So what that's going to look like is kind of this little hemisphere in some water. And we're going to be placing some mass rock inside of it, in the maximum amount, that won't sink the plastic boat. So what we know is that the mass of this hemisphere is 21 grams. We also know that it has a diameter of 8 centimeters. If we convert these into SI units, um, that'll be 0.021 kilograms. And let's actually convert this diameter into a radius so that we can more easily find the volume of this hemisphere later. So that will be a radius of 4 centimeters, and then converting that into meters would be zero point zero 0.04 meters. Um, so now, how we want to approach this problem is we want to find out what the uh, how to find that largest mass. What is the relationship between uh, larger mass and like not floating? So we know that if this is the boat and rock system, there's some buoyant force acting on it. There's also a force of gravity on the rock, in the boat, and the boat itself. And I'm going to draw that as H for hemisphere, force of gravity H. So in theory, these two should add up to be equal to the force of buoyancy when you have the maximum mass for your rock. So we can also write that out as force of buoyancy is equal to the force of gravity on our hemisphere plus the force of gravity on our rock. Um, Remember that the force of buoyancy is just the density of the fluid. In this case, it's water, and then the volume that the object is taking up. In this case, it's a hemisphere, and also it's times the gravitational constant, just g, and that's equal to. We're just going to write this as mg, and that m is of the hemisphere, and this m will be for the rock. Since all these equations have a g, we could just cancel those out. So we're left with density volume equals mass plus mass. So then from here, all we want to do is solve for that maximum mass of the rock. So if we have that maximum mass of the rock, it's just going to be mr is equal to uh, the density of water times the volume that the hemisphere takes up minus the mass of the hemisphere. So what is this volume now? Well, the volume is the mass. The volume is the hemisphere. Well, what is the volume of a hemisphere? The volume of a sphere is 4/3 pi r cubed. So the volume of a hemisphere is just half of that, which is just 2/3 pi r cubed, and that's for the hemisphere. So if we go ahead, oh, and by the way, density of water is just 1,000 kilogram meters cubed. So now basically all we need to do is just plug values in because we have this, we have the radius up here that we just plug into the volume, and then we can plug in the mass of the hemisphere. So then what we get for the maximum mass of the rock is just 0.113 kilograms, or 113 grams, for the maximum mass of the rock for your hemispherically shaped boat.